Hey guys, welcome to our channel Civil EdTech. So today we are going to learn the process of designing and analyzing of building in Etabs software. I hope you have gone through our previous video. If you haven't, please go through it once. The link is mentioned in the description box. So let's get started. So first I'll show you the default grids. Click on edit, go to edit stories and grid systems. Here you can check there are total 4 stories and 1 base, and you can also check the grid system. Click on modify grid. Here you can see that the spacing between the grids in x and y direction is 8 meter respectively. Click on enter twice and get back. Click on OK again. So first we will define the materials that we are going to use in this design. So click on define, add material properties. Now here click on add new material. Click on India, select concrete first as we are going to do RCC construction, and select the grade. Here in this design we'll select M30. Click on OK. Here you will see the properties of the material. Click on OK again. Now add another new material. This time we'll add rebar. We'll use the default value, that is HYSD grade 415. Click on OK again. Here you will again get the properties of the section. Now click on OK. Click on OK again. Now let's define the section properties. Click on define, go to section properties and select frame sections. Here click on add new property. We are going to add a concrete rectangular section. So click on rectangular section. Now let's name it. Let's name it as beam and select the material, that is M30. Now select the depth and width of your beam. Let's keep it 300 by 300. Now click on modify show rebar option. Here you have to define the longitudinal bars and confinement bars you are going to use. Now click on M3 design only, that is for beam. Here the covers you can vary. Now we'll choose 40 mm on both the side. Keep all other values as it is. Click on OK. Click on OK again. Now let's add another new property as a column. We'll continue with the rectangular section and use the same size, that is 300 by 300. Name the column as you want. Also select the material property and click on modify show rebar. Here we will select PM2M3 design column and select the longitudinal bars and confinement bars. We'll keep it same. Now the other values, let it be as it is, that is the default settings. Now click on OK. Click on OK again. Now let's define slab sections. Go to define, go to section properties, select slab sections. Here we'll add new property. Name it as slab or anything else you want. Select M30. Let all other options be as it is and only change the thickness as per your want. Let's make it 150. Click on OK. Click on OK again. So now we have defined all the structural elements. So let's draw it. Go to draw. You can select it from here, or otherwise you can use the shortcut toolbar on the left hand side of the software. So first we'll draw the beams. Select the quick draw beams option. Now change the property as we have defined it. Click on beam. Right click outside the model and select it completely. As our model is symmetrical around floors, we can do it in this way. So the beams have been drawn. Similarly, now let's draw the columns. Go to draw, quick draw columns. change the property to column and similarly draw it. So the beams have been drawn. Now let's draw the slabs. Go to draw again. Go to quick draw floor wall. Similarly, change the property to slab and select all. Now the slab, column and beam have been drawn. So now let's draw the walls for the structure. Go to draw, select auto draw clouding and select use floors option. Click on OK. So you can see all the structural members have been drawn. As there will be no slab on the base level, we need to delete it. So you can move into a structure using the up down arrows. You can check on the left at the bottom the plan view story 1 z is equals to 3 meter. So go on z is equals to 0 and on the right hand side at the bottom select one story and select all the slabs simultaneously and delete them. After deleting it, we need to assign the fixed supports at the bottom. So select base, go to assign, select joints, restraints and click on fixed support. Now apply and click on OK. So now we are done with the drawing part. So let's now assign loads to a structure. So first we'll select shell loads. So we need to select the slab section. So individually select the slab sections. You can select it individually or directly go to all stories and then you can select it like this. You can see in the 3D model all the slabs being getting selected. Now go to assign, go to shell loads and click on uniform as we'll apply uniform loads. First we'll apply the dead loads. The value will be 3 kN per meter square. Click on apply, click on OK. So now the dead loads have been applied. Now let's assign the live loads. The shortcut to select the previous sections is here. Go to select, get and click on get previous selection. So now you can see all the slabs have been selected. You can verify it on the left hand side at the bottom, that is 36 shells selected. Go again to assign shell loads, uniform and this time change it to live load and change the value as well. Click on apply and click on OK. In this model, we'll only assign the dead load and live load to the structure. We'll deeply study about the wind load in the upcoming lectures. So now we are done with assigning the loads, that is the shell. Now we'll assign the wall loads on the external beams as the walls are located only on the external face. So go to all stories option and select the external beams carefully. Make sure you don't select the slab sections. You can verify it on the 3D view. Now all the beams are selected, so go to assign, select the frame loads option, click on distributed. Here we'll assign the value as 0.2 kN per meter square. So click on apply and click on OK. As there are no walls above the top floor beam, we have to remove the load from the beams of the top floor. So select the external beams of the top floor, that is the story 4, and make sure that you are using the one story option here and select all the external beams. Now go to Assign, Frame Loads, Distributed, and make the value 0. Apply. OK. So now we are done with assigning the loads. Now let's run the analysis. It will take a few seconds to run the analysis on the model. It will view the results in the 3D view. So here it is, the display structure. You can see the displacement values has been defined for all the members. Now that we are done with analyzing, let's design it. Go to Design, select Concrete Frame Design, and first click on View Revise Preference. Check here that IS-456-2000 has been defined and click on OK. Go to Design again, select Concrete Frame Design again and click on Start Design Check. The software will run the design check. So you can see here the design has been done. Now let's check if all the members have passed the design. Go to Verify All Members Passed and click on it. Here it is mentioned that 8 concrete frames have failed the check. So we will redesign them. In case in your design it doesn't fails, so you can continue with it. You can check the value of each of the members by clicking a right click on it. Here we have selected the beam B1 of the story 4. So you can check the steel. On the top steel it is 821 and on the bottom steel it is 410. So that's the value of the steel. Click on OK. Similarly, you can check of any other member, and you can also view the detailed report of the model. Click on Reports, then select Project Report. Here you will see the detailed report. All the necessary values have been presented in this report. So that's all. This is what we have learned in the design of a building in Etabs software. I hope you watch this video and you do try this. So in the next video, we'll learn more about the wind loads and the seismic loads. Until then, thank you and keep watching.